The objective for today's lesson is that by the end of this lesson, I want you to be able to calculate the area of any parallelogram. But before we actually get started on that, I'm going to show you a picture and I'm going to give you 3 seconds to give me the answer. Are you ready? How many dots are there? Time's up. If you tried to count them one by one, there was no way you could do it. How did you try to do it? If you tried to do it by finding parts that you already knew, finding chunks you already knew, well then you're halfway to solving for area. Now the way I did it is I tried to count the bottom and then count how many rows there were. In other words, I was trying to do the arrays from when I was in 3rd and 4th grade. If you remember doing arrays to learn how to multiply, you already know how to do area. If you can multiply 2-digit numbers by using the 4-box method, that's actually the area model. So you already know how to do that. Look for groupings that are easy for you and count them. So this picture here, even though it's not square units, you're actually counting circle units, it actually relates to area also because you're using arrays. You have actually been doing this for a while. So before we actually get into the parallelograms and we actually solve the area, let me ask you first, which one's easier to do? Actually, I kind of think A is easier to do because there's only 2 numbers to deal with. I could just look at A and say 6 times 10 is 60. The area of A is 60 centimeters squared. Boom, done, like a rock star. When I look at B though, there's 3 numbers, so it makes it a little harder for me. But once I know the difference between base and height and any old length sides, I know that I am not doing anything with the 10. I'm simply multiplying 15 times 8. And 15 times 8, well, that's a little harder for me. $15 times 8 is actually 120. So A is easier, but I can solve both of them. Let me tell you the strategies that I used for solving for area. First, I have to recognize that it's a parallelogram. A parallelogram is a quadrilateral with 2 pairs of parallel sides. The opposite sides are equal length and of equal measure. So when I look back at A and B again, on A, the bottom is 10 centimeters, but the top is also 10 centimeters. I don't know the length of the other 2 sides, but I don't need to know them in order to do the area of a parallelogram. But if I look closely at A, the side and the top are not the same length, but the side and the side are the same length, and the top and the bottom are the same length. So a parallelogram has 2 pairs of parallel sides, and each pair is exactly equal to its opposite side. So I need you to take out a piece of graph paper, and we're going to try to make a parallelogram that's exactly 20 square units. So the first thing we're going to do is just draw a line. There you go. In order for this to be a true parallelogram, it needs to be a quadrilateral. That means it has to have 4 sides, and it has to be a closed shape. So I'm going to draw the next line right along the base so I know it's easy to count. But if I have these 2 lines, my next line must be perfectly equal to the opposite line and perfectly parallel to it, like this. And now I just add the top. This is a perfect parallelogram. The question is it 20 square units? Well, I can count the length and I can count the height, and I multiply those 2 together and I realize it's way too big. So I'm going to try again. I'm going to start off with 1 line and just make a shorter base. And now I have 2 congruent parallel sides, and I just add the top. I can figure out the length, I can count the height, and it's still not 20. Let's try again. All right, let me try to make it shorter and see if that helps me get it right. So now I can draw just like this and get the length and the height, and now it's perfect. So if I take a look at these 2 parallelograms, my first question is, well, which one's the easiest one to do first? Some of you might think D is the easiest one because you could just count the boxes and decompose it into a rectangle. But I think C is easier to do because I just have to multiply two things. The question is, which two? So I'm going to start off with C. I can easily look at C and figure out the height, but the base, that takes a little more thinking. So I'm just going to write down what I know. The area equals the base times 7. And that perpendicular line that tells me 7 is the height is perpendicular to the 9 centimeters. Area equals 9 centimeters times 7 centimeters. And I multiply the 9 and the 7, and I get 63. And I multiply the centimeter by the centimeter, and I get centimeters squared. Let's try that again on D, just using the formula. I'm practicing using the formula. So the formula is area equals base times height. Now this one's easy because it's on top of a grid, so I can just count those square units. So I know that the base is 7 and the height is 5. So 7 times 5 is 35, and centimeter times centimeter is centimeter squared. To me, that's a lot easier than counting one by one because I always lose track. And that's kind of it for this video. I just want to make sure that you're practicing the right vocabulary. When you say, I drew a line and cut it, I want you to instead say, I decomposed it and I recomposed it into a shape that was easier to count. Or maybe you could say, I rearranged the edges. Sure. But instead of saying square things, I want you to use the precise mathematical term. So if you're talking about a quadrilateral or a triangle, use those words. But for a specific kind of quadrilateral, I want you to say its specific name, like parallelogram. And remember, when we're counting the inside of a shape, we're counting the area. And when we count area, we count that in square units. And that's kind of it. That's the end of Geometry with Parallelograms by Miss Brenner. Now you can walk around and strut your stuff that you know how to calculate the area of a parallelogram.